Hello, mathematicians, and welcome to the lesson on simplifying radicals, also known as Jailbreak method. Now, this is one of our favorite units to teach because it actually has a really fun story that we get to teach to help you remember how to do the actual math process. So at the top of your page, go ahead and fill in those 3 blanks. We have jailbreak, and then this is going to be our phrase for the day. It takes 2 to escape jail, but only 1 survives. And we'll kind of explain what that means with the actual math. But while you're writing this down, think in your head of a movie or a TV show or a book or whatever where there's some kind of jailbreak involved. Think about that scene, what that looks like, what are some of the aspects of it, and try to come up with kind of an idea of what that looks like. It's going to help us when we get to this math part. Now, what I think of when I think of jailbreak is I think of the cliche, like, cell full of people with spoons digging out a little tunnel, but then somebody gets caught along the way, or, one of them doesn't quite make it out, or something like that. So the reason we have this phrase is that generally it takes more than one person to escape from jail. You don't really see just one person going solo. They usually have a team or someone who's in disguise or a guard that helps them. But most of the time, somebody is going to die along the way. So we're going to kind of use that to help us remember this actual math that we're going to do. First of all, though, we need a quick refresher on just basic square roots, because simplifying radicals is actually just the name for anything that's a root symbol like that, or even a cube root or a fourth root. Those are all called radicals. So anything with a root symbol. The square root of 9 means what number times itself gets me 9. Well, that number would be 3, because 3 times 3 is 9. So the square root of 9 is just the number 3. Same thing with 144. There is a number times itself that makes 144, and that's 12. 12 times 12 is 144. However, if you type it into your calculator, there is no whole number that actually equals 12 when multiplied by itself. In fact, when you do it, I think it comes out to kind of a crazy decimal. And I'll even type it in just to see. Yeah, we get 3.46410, It keeps going on without a pattern. We don't want to have that. That's not a very exact answer, but there is a way to help simplify the square root of 12, which is what we are going to do. So we have a couple of steps for that. And you can even put no whole number. So there's no whole number that equals the square root of 12. It's a decimal. So in your notes, you have one step to fill in, and it's that our first step is we make a factor tree, so kind of hearkening back to middle school when you learned that, and circle the prime numbers. So that goes in your very first blank under the steps section of our notes. Now, something you kind of need to know in order to understand that step is what the heck prime numbers means. A prime number is any number that can only be divided, hopefully you're remembering it in your head as I say it, only be divided by 1 and itself. So, for example, the number 2 can only divide it by 1 and 2. 3 is also a prime. I can only divide it by 1 and 3. 4, I can divide that by 1, 4, and 2, so that's not a prime. 5 is a prime. I can only divide that by 1 and 5. 6, not a prime. I can divide it by 1, 2, 3, and 6. So that's just kind of a quick example of what prime numbers means. So we're going to do these first 3 examples, and we'll tie in that jailbreak concept as soon as we get our factor tree done. All right, so I can split up 90 into a couple things, but I need to make sure they multiply to get 90. Well, the first thing that comes to my head is 9 times 10. Now, you could do 2 times 45. You could do 30 times 3, and it doesn't matter. You're going to get the same exact circled answers that I do, so don't worry about picking different factors. 9 is not a prime number because I could split it into 3 times 3. I can't split up 3 anymore. I can only split it into 1 times 3, which means it's a prime. So I'm going to circle that, just like we had said, which means that one's a prime too. So let's go back to 10. 10 I can split up into 1 times 10, but that doesn't help me because then I get a 10 all over again. But I could split up into 2 and 5. We talked about 2 as a prime and 5 as a prime because they don't split up into anything. Remember, it's got to be something I can multiply to get it. So that's my whole set of prime factors of 90. Now, if you look at your steps up at the top, our first step was make a factor tree and circle the primes. Second step was rewriting all the prime factors in a radical. Now remember, a radical is just a fancy name for this. And here's where our jailbreak method comes in. Now we talked about when you break out of jail, people normally have a team of people. They don't usually go by themselves. Well, we're going to think of this radical as the jail. And all of our whole numbers are stuck in jail. And they can only break out if they have a partner. Well, if we look at our numbers, there's 1, 2, there's 2 3s, and there's 1 5. So the only set of partners, quote unquote, that I have are the 3s. So circle those. Now remember our phrase that we talked about for this section is it takes 2 to escape from jail, but only 1 is going to actually survive. Kind of like in Jailbreak in real life, people when they try to escape from jail, normally one of them dies along the way or gets shot by a guard or something morbid happens. So with this one, we're going to get those guys out. However, this guy gets trampled on the way out. He's not going to make it. He died. So that 3 is out, which means this 3 is now broken out of the jail, quote unquote. So he's on the outside. Now 2 and 5, they can't pair up. Like we said, it takes 2 of the same number to break out of the jail or the radical. So they're stuck inside. And I can reduce that back down a little bit. So I'm going to make it 3 square root of 10. And that is my final answer. The simplified version of square root of 90 is 3 times the square root of 10. Now what I'm really doing here, besides the jailbreak story, is I'm finding perfect squares. In other words, 3 times 3 is 9. Well, what is the square root of 9 that we talked about? The square root of 9 is 3. That's why this 3 can come along on the outside. But 10 is not a perfect square, so it gets stuck on the inside. So let's try 8 now. The only things that multiply to get 8 are 4 and 2. Again, 2 is a prime. 4 I can split up again into 2 times 2. And I have nothing else to split up, so that's a pretty easy one to make. So let's draw up our jail, our radical. And we'll write all of our numbers in order. And again, remember, our phrase is it takes 2 to break out of jail, but only 1 is going to make out. There's only ever 1. So even though there's 3 of these, I don't want 3. I only need 2 to break out of prison. So I'm going to circle 2 of them. This loser got left behind. He was snoozing during their plan making, apparently. They're going to try and bust out of jail. They're using spoons to dig out of the tunnel. But the tunnel caves in and this guy dies. Only one of them is going to make it out. So we've got our radical, our prison. This sad little loser 2 gets stuck on the inside. This guy broke out of jail, so he's on the outside. And this guy died. Now notice this 2 is a big number. It's not a tiny number tucked in here. It's not an exponent or anything. It's a whole number, same size as this one. So 2 square root of 2 is my final answer. All right, last example on this page. 32, you could split it into 2 times 16. You could split up into 4 times 8. Can't split it up into 1 times 32, so don't do 1 times anything. But I'm going to do 8 and 4. Both of those can be split up a little more, so 4 is 2 times 2. And 8. Something we did notice, by the way, is a lot of people were doing this. They were saying, oh, 4 and 4 makes 8. Well, remember, we're doing multiplication, so you can't do that. Okay, so be cautious about that. Make sure you're multiplying. So it's 4 times 2. That 2 is a prime, and then we have 2 times 2 for that other 4. So I have 1, 2, 3, 4, 5 2's in prison. All right. Now again, my phrase is it takes 2 to break out of jail. So obviously I have a lot of 2s to work with here, so I can circle that group. I've also got 3 left over though, so I have enough to make another pair to break out of jail. So I'm going to circle a second group. This one doesn't have something to partner up with, so he's stuck in jail. These guys are busting out. They commandeered a dragon, but the dragon ate this one, so he's dead. These guys stole a horse, rode the horse out of the prison, but this one fell off the horse's back and he died. It's a very morbid section of our notes. So these guys are out. These ones made it out of jail, so my prison is still here. There's still this 1, 2 left on the inside. Now when these ones break out of jail, I have 2 2s, and they actually are still multiplied together. Do not add them. I know it happens to be the same number this time, but you always are multiplying. So it's 2 times 2 on the outside, which is actually 4 square root 2 for our final answer. That is the simplified version of square root of 32. That's what we're doing, is we're simplifying them, kind of like with fractions. You can't leave a fraction unsimplified, so same thing with radicals. We want to simplify them. Okay, you guys are going to do this section, so feel free to pause here. I'm not going to go over them. You're going to check with your teacher in class, and then I'm also going to do some of the problems on the back so that you are able to do that as well. So make sure to come back and do these. Now on the back side, what do you think will happen if we change the root to this? Now notice there's a little 3 here, a little bit different than before. I don't know why this theme keeps moving. There we go. Okay, so what's the difference between this and this? Well, we called this the square root. And really what you don't see here is there's really a little 2 tucked in there. Kind of like how x is really equal to x to the first power, but we don't write it because it's assumed that that's the case. There's no first root of something because then it would just be the number. So the smallest root that we can have is a square root, which is a 2. So normally we don't write the 2 in there. So that's why it's not normally there. This is the next level up. This is the cube root, or you can call it the third root. Either way works. And it's actually going to be the exact same process, but we like to call this the higher level security prison. So before, this was a 2-level prison, which meant that it needed 2 people to break out of jail. Now think about in the movies when it's like a maximum security, you have extra guards and extra booby traps and extra whatever. So there's generally a bigger team of people that have to break out of jail. So same process here. If there's a 3 here, that means you need 3 of the same number to break out of prison, but it's still only 1 that makes it out alive. It's never going to be more than 1 of the number. So we'll go through this one to show you. Think about what times what is 24. 6 times 4 is the first thing I think of. You could do 2 times 12, 3 times 8, any of those work. As long as you're breaking it down correctly, you'll get the same exact prime factors. So 2 and 2, and then 3 and 2. So there's my prime factors. This time I have a 3rd level prison. I'm going to write them in order. So 2 times 2 times 2 times 3. 1, 2, 3. So I got them all. Okay, and again, it's a 3rd level security prison, or a cube root. I need 3 of the same number to break out of prison. This number is obviously not going to make it out. But again, takes 3 to break out of jail, only 1 is going to survive. This guy gets attacked by a dog, and this one gets attacked by a very aggressive cat. So they die on the way out. This guy makes it out, so there's a 2 on the outside. Remember to keep that cube root there. Notice it's kind of like tucked into this little tail of the radical. And the 3 is still left in prison. So there's my final answer, 2 cube root of 3. Now, the rest of the page, you've got some square roots, you've got some cube roots. 4th roots, same exact process. It just means that you need 4 of the same number to break out of jail. So anything that I did not go over is your assignment. So you need to complete everything else on the front side and the back side.